Hello everyone, I'm Frank and welcome to Frank Puzzles. In the month of October, I'm going to be trying to upload 2 videos every day, one of the very easy or easy difficulty, and one of the average, hard, or very hard difficulty. And now on to today's easy puzzle. Or actually, no, this is a hard puzzle, or this is an average puzzle, so it's the non-easy puzzles. And it's called Pinched by Black Doom. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, every column, and every box. Hit point sandwiches. A number outside the grid gives the sum of digits between the only 2 digits in that row or column that match their position numerically when looking in the direction away from that clue. For example, a row of with a 35 clue on the left. Okay, let's just say this one was 35. Might be filled 1, 1, 8, 7, 6, 2, 4, 3, 5, and 9. So the 1 is in the position that matches. The 1 matches its position numerically, and the 9 matches its position numerically. And no other digits match their position numerically. So this would add up to 35. Okay. That works. German whispers. Adjacent digits on the green lines must differ by at least 5. So for example, if this was an 8, this would have to be a 1, 2, or 3. This would also have to be a 1, 2, or 3. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so interesting. Between the only 2 digits in that row or column. So the hit point sandwiches is interesting. The number outside the grid gives us a sum of the digits between the only 2 digits in that row or column that match their position numerically when looking in the direction away from that clue. So there has to be, first of all, there has to be 2 digits, 2 and only 2 digits, which match their position. So that means one of them has to be 4. It has to, so in this 4, there has to be a difference of 1 or 2 between those positions. Right? It could be anywhere though. Interesting. So that, okay, and for 30, that means it has to be maybe the 30 is easier. 4 is hard because there could be any two. It could be any two, or it could just be one, right? And we don't know where. 30 is a little bit more constraining because 30 has to have oh. It's not that constraining actually thinking about it. It could have 6, 7, 8, 9, right? Oh, it can't be 6, 7, 8, 9. No, that doesn't work. So say it was 6, 7, 8, 9 in this column, right? If you had 6, 7, 8, 9, you would have to have, first of all, this one would have to be at least one part of the sandwich. But if it's 6, 7, 8, 9, this would have to be the other part of the sandwich, which would be 6, which can't work. So it cannot be 6, 7, 8, 9. Can it be interesting. Can it be a set of 5? I don't think so. A set of 5 can be at minimum, has to be at minimum 2, 6, 7, 8, and no, 2. Okay, so the problem is a set of 5 means one of these has to be 7, 8, or 9, right? I guess it could be 5, maybe. Right? If it's 5, this would have to be 8 and 9. This could be 7. Okay, so one of these has to be 7, right? It's a set of 5 at least. It cannot be a set of 4. So we've shown that 4 set of 4, it doesn't work, right? Because this would have to be 6, 7, 8, and 9. That would have to be a 6 because it would have to match the endpoints. So we know one of the endpoints is here. One of the endpoints has to be here. So it cannot have a 7, an 8, and a 9. But I think it could be 5, right? If it's 7 here, this could be 5 plus 6 plus 8 plus 9. So it's 28, and then we have a 2. Yeah, so that works. On the other hand, so it has to be at least 5. So then it's at least here, right? Can it ever be here? So this would be a difference of 3 and 9, right? So you have 4, 5, 6, 7, 8. I guess that could work, right? 4, 5, 6, 7, 8. And then this would be 2, and that would be 1. So this could be 3. That could be 9. So none of these are in the right order. Okay, so similarly here, this has to be the ends, and this one cannot. 18. 18 is very, there's a lot of possibilities there. Okay, so 4 could be 1 and 3, and that would be 4. This could be 2 and this would have to be 2 and it can't be 2, first of all. So it could be 1 and 3, and that would be 4. That's fine. Can it be 3? No, this cannot be 3 and 5. It could be 3 and 6. No, it can't be 3 and 6. Oh, so it can't be 3. No, it could be 3 because it could be 1 and 3, right? So 1 and 3 here, and that would be 4. 3 and 6 doesn't work because it cannot be 1 and 3. 3 and 5 doesn't work because that would have to be 4, and then they would both be valid sandwich points. So it could be 1 and 3. Can it be 4? It would have to be 4 and... Okay, so the possibilities right now are 1 and 3. 4. It could be 4 and 7. It could be 5 and 7. And that would be 4. And this would have to be 9 and 9. If that's 5, 7, that's 4. That would be 9. Yeah, there's many possibilities. It could be 6 and 9. And it could be 7 and 9. Yeah. Not helpful. So it could be all of these. Okay. Right. 4 plus 5 plus 6 plus 7 plus 8 is 30. So 3 and 9 works. 2 and 9 probably works also. This would have to be a 4, and this would have to be 1, 5, 6, 7, 8. 1, 3, 5, 6, 7, 8. Yeah, so 2 and 9 works. 1 and 9 does not. Does 1 and 8 work? 1 and 8, this would be 6. Yeah, so that works too. Okay, so if this is 3 and this is 9, this would have to be some sort of 4, 5, 6, 7, 8. So this would be 1, 2, 1, 2. Specifically, this would have to be 1, and that would have to be 2. And this would be 4, 5, 6, 7, 8. So the 3 and the 9 work. The 2 and the 9 would force this to be 4. So that seems fine. The 1 and 9 does not work. Okay, so that's just 9. 1 and 7. 1, 7. This would have to add up to 15 then. So it adds up to 8 right now. It could be 2, 5, or 3, 4. Yeah, that would add up to 15. This can't be 5, so this would have to be 2 and 5, and 3 and 4, 3, 4. So yeah, 1 and 7 work. 2 cannot be with 7 because it has to be at least 5. So 1 and 7 works. 1 and 8. So we tried 9 and 3. We tried 9 and 2. We tried 9 and 1. 9 and 1 doesn't work. 9 and 3 does work. 2 and 9 works because that's 4. 1 and 9 does not work. 1 and 7 works with 2 and 5 and 3 and 4. 1 and 8 works with 6. So then we just have 2 and 8, because 3 and 8 cannot work together because that's only 4 apart. So this is the same for both. So you have 1 and 7. This would, if this is 7, this would have to be 1, 2, 1, 2. So this can't be 1 or 2, so this would have to be 3, 4 if it's 1, 7. 1, 8 works if this is 6. 1, 9 does not work. So we tried 1. 1, 7, 1, 8 works. 2 and 8. Okay, so 2 and 8 for both of them means it would have to be 1 and 4 on the outside. So this would have to be 1, this would be 4. Right? So 2 and 8 means this is 4 and this is 1 specifically. 2 and 9, we already worked that out here. 2, 9, 2, 9. And this was 4. And this, then it could be 3 and 9. And this would have to be 1, and this would be 2. Oh, interesting. Okay, so this is low. This has to be high then. So this could be 6, 7, 8, 9. This is also low. 1, 2, 3, 4. So we know for certain this is 1, 2, or 4. We don't actually know anything about these two. We don't know anything about these two. This is 1, 2, 3, 4, 6, or 9. This is 1, 3, 4, 6, or 9. Interesting. Okay, so we don't know anything about this. We don't know anything about this. We definitely know, so we know the outer edges. We don't know anything in between because it could be 1 and 8, in which case that could be, we know the outer edge. I mean, basically, this could be inside that, right? So this could be 1 and 8, or this could be 2 and 9 for this side. So yeah. Obviously, they both can't be, well, maybe. Uh, Interesting, though. If this is 2, so say this was a 2, right? This cannot be 1. So this would... this would have to be 4. And this could be 8 or 9. This cannot be 4, so this is 1 or 2. We don't know what this is, though. So this is either 3 and 9, or this is 1 and 7 or 8. This is 8 or 9. Interesting. What does that mean, right? This is 1 or 2. The 2 can only be 1 if this is 3. Otherwise, this is 1. That seems fine. I mean, no, this can't be 3. So this can't be 2 in that area. This is 1 or 2. Which means 7, 8, and 9 are all in play because it could be still 1 and 7, right? And this would be 3, 4. This is either 8 and that's 1. 1? Yes. 8, that could be 8 and that would be 1. Or it could be 9 and that works. And then this would be whatever. Oh, so this would have to be 1 or 9 specifically. This is either 8 and 1, or this is, yeah. Or this is 9 and whatever. Okay. This could be 2, 1, 3. So, wait, the 1 does have to be here then. Right? Either this is 1, and this is 7 or 8. Or this is 3, which makes this 1 and 2, because this would have to be 3 and 9. So either way, the 1 cannot be there if this is the case. Interesting. Okay, so then this cannot be 3, though. If this was 3, this would have to be 9. This would have to be 1 and 2. Right? Because we know 4, 6, 7, 8 has to be here. But that forces this to be 4, which forces this to be 9. And then this would be valid, but there's no way it could be 18 here. So then we know for certain this has to be a 1. So this is either 7 or 8. We don't know which. So this can't be 3 here. This can't be 1. This cannot be 9. We know that for certain because the 2 and the 9, yeah, these 3 digits would have to add up to 27, which is not possible for 3 digits. Unique digits. So this would have to be 1. There's a 7 or 8 with it. Say this was 8, right? If this is 8, then this would be 9. This would be 6. That seems fine. That seems fine. Okay, that didn't help us much. We do know there has to be 2 from 1, 2, and 4 there, right? It's possible it could be 2, 4. Oof. Hit points. 17. Could be a lot of things. That's the 30 is the most constraining thing we have. Uh, hmm. 18. Hmm. I mean, this could be 4, though. That's the problem. This could be 6. That would be 1 and 1. Does the 18 give us anything? Not that I can think of. 18's so broad, right? It just means that 27 has to be outside. Well, 18 has to be 3 at least in between, right? Um, right. So what works for 1 does not necessarily the same for this, right? Because this could be a 2. In which case, yeah, it just doesn't. Oh, yeah. So it could actually be 2 and 5 even. Yeah. That doesn't, yeah. There's nothing there either. Um, hmm. 18 means you have to have 3 digits that are in between the two position numerically correct cells. So there has to be at least 3. Hmm. This is difficult. This is supposed to be average difficulty. I'm not sure what, yeah. So there has to be 3 cells at least, which add up. So this is between 3 and 5. Right. Can it be 5? Say it was 5, right? That means it would have to be. What's the minimum to make 18? Or sorry, the maximum, I guess? 18 would be 3, 4, 5, 6 forms in 18. Um, 3, 4, 5, 6 forms 18. No, no. Yes, 3, 4, 5, 6 that forms 18. So for 5 digits, it would have to be 1, 2, 4, 5, 6. So 2 would always have to be in the oh, into the 5 digit. But that doesn't say much, right? Because it could be 3 digits, it could be 4 digits. Those both work. 3 digits could be up to 189. Yeah. Hmm. That is one thing that's interesting, right? If you have one for one row, that eliminates all the other possibilities for that being the position numerically correct position cell in that for all of these, right? Oh, interesting. Oh. There's only Okay. Okay. That's the clue I think that actually makes it work. In this cell, there are in this column, there are two numerically position or yeah, two cells that their digit matches their position numerically. And it has to be the same for each one, right? So if this was a 1, that would work. If this is a 1, that would work. If that's a 1, that would work. If that's a 1, that would work. So each of them can only have 1 from 1 through 4. Sorry, it has to have 2. Yeah. So if this was the correct position, that would be 1. That would eliminate all the other ones for here. Similarly, if there's a 2, or yeah, if there's a 2, that would eliminate all the positionally correct digits for 2. So, and we know each one has only 2 and only 2, but that would eliminate 2 from the others. So we know for the positionally correct cells, the cells that the digit matches their position, there's 2 unique ones here, there's 2 unique ones here, there's 2 unique ones here, and there's 2 unique ones here, and they have to be unique across all 4 columns. So that means there's 8 that has to be taken care of, which means one of these is 4 or 6. And since one of them is 4 or 6, the other one has to be 4 or 6. Right? Or it could be 5, I guess. Yeah, it could be 5. Basically, at least 2 of these have. One of these has to be 4, 5, or 6. The other one has to be 4, 5, or 6 because these don't take care of that. So these are going to be unique. These guys are going to take 4 away from 1, 2, 3, 7, 8, and 9. These can only have 2 in 1, 2, 3, 7, 8, 9. And the other one has to be between 4, 5, and 6. And it cannot have 2 between 4, 5, and 6 because there's not a big enough difference, right? There's not a big enough sum. So between this and this, the most you can have is a 9, right? So therefore, there's only 1 in 4, 5, and 6, and there has to be, I guess it could be 5, and it could be 1 or 9, right? The other one has to be 4 or 6, and it has to be right. If it's 4, obviously it could be 7, 8, or 9. Oh. So this is 4, 5, or 6. This is 4, 5, or 6. First of all, these can't be 5. Ah. One of these is 5, one of these is 4 or 6. So either this is 4 and this is 6, or this is 4 and this is 6. Interesting, right? Because either this is 4 and that's 6, so that matches. It can, first of all, these can never be 5 because of the German whisper lines. So these can never be the correct thing to go from. If this is 4 and this is 6, you have to have 3 or 4 in between. So it cannot be any of these. It would have to be at 8 or 9. It would have to be a 1 or 2. And that works either way, right? If this is a 4, well, if this is 4, this has to be 9. This would have to be 8. This would be 6, 1, and 1. So if this is a 4, it has to be paired with an 8 or a 9 because none of these work. Because this would be at most 4 and 1, which means 17. So this would have to be paired with an 8 or 9. This would have to be paired with a 1 or 2. It can never be 3. Right? If the 6 is paired with a 3, aha, and I think this solves the other part. If the 6, if there's a 6, and we have to have a 6, actually, we know that. This is 4, this has to be 6, right? If this is a 6, it cannot be paired with a 3 in that row because this is only 2 cells in between, which only can add up to 17 at most. So it would have to be a 1 or a 2. If it's a 4, it's the same logic. It can't be paired with a 7. It has to be paired with an 8 or a 9, because if it's paired with a 7, these two only add up to 17 at most. So we know one of these is 3 and one of these is 9. We know one of these is 1 and one of these is 7. So that's a guarantee. We know one of these is 1. We know one of these is 7. We know one of these is 3. One of these is 9. Therefore, the 2 has to be here. So neither of these can be 2. So this has to be either a 1 or a 2 or 4. This is a 1 or a 2 or 4. So the 1 goes to 7. So it's either 2, 5. So you have either the 1. Okay, let's clear all this stuff. Either you have a 3, 9 here, in which case this has to be 4, 5, 6, 7, 8. And therefore this would have to be 2 and 1, but the 2 cannot be in the matching position. So this would have to be 2, 1. Or this is 2, 1, right? And this is 9. Then the other one has to be 1 and 7. So this would have to be 1, and that would be 7. So we have 1, 2, 1, 2, right? 7, 7. If it's 1 and 7, it could be 2, 5 on the outside or 3, 4 on the outside, because the 4 digits on the outside have to add up to 15 here. But this can't be 5, so this would have to be 5 and 2, or it could be 3, 4, 3, 4. This one would straight up have to be 3, 4, right? So we know both endpoints, right? This has to be 1 and 2 and 1 and 2. So this could be 6, 7, 8, 9. This is 1, 2, 3, 4. Or this, and this is 3, 4, 9. This is 2, 3, 4, 9. So this could be 6, 7, 8, 9. 1, 2, 3, 4 works. So if this is 3, this would have to be 8, 9, 8, 9. So we know the 2 has to be one of these. We know the 7 and the 9 has to be one of those. So this has to be the 8. So there's sets of 3, right? So if this is 4, it would have to be 8. This would be 9. Okay, so this, this situation, 8 has to be one of these, 6 has to be one of these, 4 has to be one of these, 2 has to be one of these, right? If this is 4, that means this is 6. If this is 4, that means this is... let's do the other way, because we know that the German whispered limits a lot. If this is 4, this is 6. So this would have to be 2. This would have to be 8. This would be... this cannot be 9. This would have to be 9. That would be 9. This would be 1 and 1. Ah, and this does not work. Because there's 3 digits between 2 and 6, which are the only correct ones. And there's no 9 possible in either of them. So there's no, it cannot be 1 plus 8 plus 9, which is what it would have to be to add up to 18. So this cannot be the 2 and the 4 and the 6. So the German whispered lines cannot be the correct ones. So this is 4, this is 6, which makes that 8, and this 2. We know this is at, cannot be 4. So could be at, this is at most 3 and 9. So this is 12 at most. So this has to be 6 or greater. It obviously can't be 6. This is 7, 8, or 9. This could be 3 and 9 also. So this is 6, 7, 8. So 6, 7, 9 also, right? Because these two digits can only be 3 and 9 at most, right? Because you have the German whisper line issue. So this is a high, this is a high. I don't know how much that tells us. 7, 8. Oh, this can't be 7. So it has to be. Okay, so the 9 is taken care of here, right? If this is 6, this has to be 3, 9. So there cannot be a 9 on the outside here. So this could be 1, 3, no 4, 5, 6, 7. This is 1, 3, no 4, 5, 6. It could be 2, 5, 6, 7. It could be 2, 7, 9. Yeah, that's valid. This would have to be 2 and 7, though. This can't be 7 because one of these is 7. One of these is 9. One of these is 1. One of these is 3, so this can't be 3. This can't be 2 either. So it could be 1, 4, 6, 7, 8, 9? Yeah, because it can't be 2. It could be 4. Can this ever be 1? Yeah, 1 and 8. That seems fine. 1, 8, and 9. This could also be 1 and 8. This is a 4. It's a 4 in position. So this is the this is the 1, which means none of these are valid for this one. Oh wait, that could be. So this could be a 7. This could be a. No, it has to be 1 and 3. Therefore, we know this is a 7. There has to be a 1 and 3 in between. So this is 1 and 3. Okay, there we go. And this has to be a 7 for this one, for this row. So this is 1 or 3, which means this has to be 6, 7, 8, 9. This is 1 or 3 with it. If it's 1, it has to be 8 and 9. If it's 3, it also has to be 8 and 9. It cannot be an 8 there, though. Sorry, it cannot be a 9 there. If it's 3 and 9, this would be 6. So if it's 1 and 8, the other one has to be 9. If it's 1 and 9, the other one has to be 8. Right, this is 1, 3, 1, 3. Oh, this is 6 is in the correct position. This could be, it cannot be 9, right? If it's 9, 2 digits cannot add up to 17 then. So none of these are valid. This one still could be. This one still could be valid. So for this row, we have 4 and 7. For this row, we don't know. It cannot be either of these two. So it's 1, 2, or 3. So this is 1, 2, or 3. We know this can't be 1, 3, 4, 6. So one of these has to be 2. So this has to be 2. If it's 2, it has to be 2 with 7 and 9. So this is 2, 7. Right, and this is 9. So there's no 7 here. There's no 7 here. Right. This had to be 2 because this can't be 1 or 3. So this becomes 5, 8, and 9. So there's no... This is 5. So this is 2. This is the 1 that works. I guess I should just... Well... Anyways. Let's just not do it for ones that we know what the values are. So this one can't be still. So these are fine. Because it gets confusing in the cross thing. So for the cross, we have 4, 6, and 7 already taken care of. 2 cannot be for this one. Okay. So this is 2, 7, 9. So this cannot be 8 or 9. So if this was 2, it would have to be 6 or 7. It can't be 7. So this is 6. Or it's 1 or 2. Oh, can't be 7. Because we know this one of these is 7. So this is 1 or 2. This has to be 7. This is 2. So this is 1 or 2. One of these is 1, 2, or 3. There's a 7. So it cannot be 3 anymore. It could still be 2. It could be... No, it can't... It could be 2. This would be 1. Can it be 1? If this is 1, and this is 6, what could be in between that adds up to 17 with a 7? You say you have a 7 and a 5, that's 12. And then it would have to be 2, and that's 3. Interesting. Okay. So if this is 2, that would work. It can't be 575. It can't be 875. Okay, so if this is 2, so 3 no longer works because it can't be 8, 9. If it's 2, it cannot be 575. It can't be 872. It would have to be 971, right? If it's 1, the only one that could work is 5 and 2 and 3. This can't be 2, so this would have to be 3, and this would be 2. So we know in this case, 1 is here, and 2 is here. So this is 2 or 3. This has to be 2 or 3 specifically for this to work. And because that is the case, this cannot be 3. Because if this is 3 and 9, this has to be 2 and 1. And that eliminates all the possibilities. So this cannot be 3. Therefore, we know this is a 1. So this is 1. This has to be 7. This is 3. This is 9. Which makes this 2 and 1. And this one we don't know. This one we cannot be 9. So this has to be... can't be 6. Can't be 7. Can't be 8. This has to be 9. And this is 1, 2, 3, 4. So this cannot be 1. This has to be the 1 because it's the only place that could be 1. So this is 1. This can't be 1. This has to be 4, which makes that 9. So it could be 3, 7, 8, or 1, 8, 9, 8, 9. Okay, so one of the ones is here. This is 1. So 1 has... Oops. Not the big number. It has to be one of those two. So 1 is here. 2 is here. 2 has to be here. So, and it cannot be here or here or here or here. So this has to be 2. Okay, now we're looking at 5, 6, oops, not 2, 5, 6, 8, 9. No 9 here. This is 5, 6, 8, 9. No 9 here. This is 2 or 3. This is 2 or 3. So there cannot be a 2 or 3 anywhere else. So no 1, 2, 3, or 7. So we have 4, 5, 6, 8, 9. This can't be 4 or 5. Therefore, so this can't be 6. This has to be the 2, because that's the only low one here. And this is 3 or 4. So this is 8 or 9. This can't be 2. Okay. So now we know, okay, so let's clear these. And clear these. So that's 1 and 7, that works. 4 and 8, that works. 2 and 6, that works. 4 and 7, that works. 6 and 1 or 2, we don't know which. So it's one of those two. So we can clear out all the gray coloring. So we've solved this one, we've solved that one, we've solved this one, we've solved this one. Okay, so this is 4, 5, 6, 7, 8. It's no 6, no 6 or 7, no 7, no 7, no 8. This cannot be 4, 5, or 6. This has to be 8. So this is 8, which makes this a 1 or 3, and this is 1, 2, 3. So this cannot be 8. This is 4, 5, 6. This has to be a 7. We have 1, 3, 6, 7, 8, 9, 7, 8, 9, 8, 9. This has to be 4, 5, 6, 8, 9. One of these is 1. So we have 3, 8, and 9 left. So 9 has to be here. This could be 3 or 8. This could be 3, 8. This cannot be 9. Three, 2, 5. So this is 3, 7, 8. So the 8 is one of those two. This cannot be 1, 2, or 6. 3, 4, 5, 7, 9. It cannot be 8. This can't be 8 or 9. So 1, 3, 4, 5, 7. No 7 here. Okay, so this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. This cannot be 7 or 9. We have 5, 6, 7, 8. 5, 6, 7, 8. So 7 cannot be here. This has to be 7. We have 1, 3, and 8 here. And they're guaranteed to be 1, 3, 8. Therefore, this is 5 and... Oops. This is 5 and 6. This can't be 7. So this could be 7. One of these two is 7. So 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. It cannot be 5 or 6 because of these two. Therefore, the 6 has to be here. This has to be 5. So this cannot be 6 here. This cannot be 5. That can't be 5. Therefore, this is 5. That can't be 5. We don't know what these digits are. We just know there's a 1 and a 2 there. If this is 2, this is 1 and 9. If this is 1, this is 3, 2, 5. So if this is 2, this is 1 and 9. The 8 could be there. Oh, interesting. If this is 3, 4, 3, 4, this is 1. If this is 2 and 5, this is 3, which would force this to be 1. And this would be 3 or 4. This is 1, 2, 3, 4 also. So one of these is 1 or 3. One of these is 1 or 3. Oh, the 8 has to be here, so this cannot be 8. Interesting. So if this is... Okay, so if this is 2, this becomes 1, 7, 9. This is 3, 8. So this has to be 4 or 5 if that's the case. So this is 1, 4, 5. We know this is 1. This cannot be 1, 2, or 9. So we have 3, 4, 5, 6, 7, 8. No 6, 7 here. This is 3, 4, 5, 6, 7, 8. This is also 3, 4, 5, 6, 7, 8. So that can't be, oops, that can't be 7. So now we have all the numbers here, right? Which means this is 8 both times. Is it? Yeah, because either this is 1, and then this would have to be 3, 2. Or this is 2, this would be 1, 9, this would be 3. So this would be 8. So this is 8 both times. So this cannot be 8. And now this, oh, okay, so this one is the correct one. This one is not. This one is not. This one is not. This one cannot be because this is only 3. This one can't be because there's no 4. So this one has to be the first one, right? So this has to be 3. Yeah. So then this one has to be the correct one. Which means 18, so it's 5 digits that add up to 18. Which means 1, 2, 4, 5, 6. Yeah. So this has to be 5, 6, 5, 6. 1, 2, 4, 5, 6. So this is 4, which means this cannot be 4. This is 7 and 8, so this has to be 8, and this is 7. This is 9. No 8, 9. This has to have the 6, so there's no 6 here. This can't be 7. This has to be a 5. So we have 4, 6, 4, 6. So this is 4. This is 6. There is no 6. There's no 6. There's no 5. There's no 9. 7 has to be here. This can't be 5. So this becomes 5, 6, 5, 6. Forces this to be 8, 9. No 8, no 8. 5, 6, 5, 6. And yeah, so this 3 and 9, there's 1, 2, 3, 4, 5, 6. This is 1 or 2. This is 1 or 3. This has to be the 7. And we have 1, 2, and 8. So this is 8. And this is 1, 2. So if this is 2, this is 3, and that would have to be 1. So that works. 2 and 5. This is 3, 5, 8, and 9. So what okay, so then we've gone through all the scenarios here. But what does it mean? Okay, say this is 2, 5. If this is 2, 5, this is 3, this is 6, this is 4. 2, 5. This is 3, so this is 2, 5, 4, 9, and this is 1. 1, 3, 2. So this becomes 5. We have 2, 5. This is 1. This is 2. That seems to work. Okay, what if it's 3, 4? Okay, so if it's 2, 5, this is 3. Oh, okay, one thing is, this is either 3, 7, 8 or 1, 8, 9. So this is 3 or 9. This is 3 or 9. This cannot have a 3 or a 9. So the 4 is here. This is 1 or 7. Well, this is 1 or 7 too. So the 3 has to be one of those 3. The 3 has to be one of those 2. Oh, hold up. Can this ever be 7? I guess so. If this is 7, this is 8, 9, and it's 1. can it be 8? If this is 8, this is 7, 3, 8. If it's 6, this is 8, this is 7, 3, 8. Oh. No, 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 no. Okay, we have 8 and 9. This has to be 1. That doesn't tell us very much. Oh, wait, hold up. No, that could be 1, 3, or 9. Okay, we just have to go through the scenarios. Okay, so okay, we did 2, 5. That seemed to work okay. What about 3 and 4? If this is 3 and 4, this is 5. This is 2, this is 1. If this is 3, 4, this has to be 5. Okay, so this is 1 and 4. Right? This would be 1, so that would be 4. This would be 5, that's 9. It's 3. Seems fine. I think we just have to go through all the different scenarios, unfortunately. Okay, 1, 2, 3, 4, 6, 7. No 4, no 7. Okay. Okay, that's one thing. So if this is 2, 5, that's fine. If it's 3, 4, this is 3, 4, that's 2, which makes that 1. This is 3, 4, that has to be the 5. So if this is 5, that's 6, this is 3. So this has to be the 4 of the 3, 4. So this is 3 or 5. Okay, so we have this one taken care of. That adds up to 18. We have this one taken care of. That adds up to 4. We have both scenarios here for 17. We have this added up, so it adds up to... We have 17, and this is always 13. So it's either 2, 5, 6, or it's 3, 4, 6. So that works. This works because it's 2, 7, 9. We have both scenarios added for here. It's 1, 7, 1, 8, 9, or 3, 7, 8. And this is already taken care of for 3, 4, 5, 6. Sorry, 4, 5, 6, 7, 8. Right, so these are reversed. Right, so we have all the scenarios taken care of. Um, hmm. Oh, so this is 5. This cannot be 5. We just have to go through the different scenarios, it seems. Okay. Not liking that, but let's just do it. 3, this is 1, this is 2, this is 1, this is 9, this is 5, this is 4, this is 5, this is 6, this is 4, this is 5, 3, 4, 3, 4. This is 4, this is 6, this is 5, this is 6. We have 8, 9, 8, 9. This is 5, 3, 4, 3, 6. Yeah, this looks fine. So that seemed fine. Let's try 2 and 5. 2 and 5. This becomes 1. This is 2. This is 3. This is 5. This is 1. 4, 9. Oh, both cases this is 1 and 3. Wait. No, that can't be right. Oh, I think I just did 2 and 5. So if it's 3 and 4, this is 2, 1, 9. This is 4. This is 1. This is 2. This is 5, 6, 5, 6. This is 3. This is 5. This is 6. This is 5. This is 3. This is 1. This is 3. This is 9. This is 5. This is 8. This is 7. So this is 3, 1, 6, 4. That's a 1. This has to be 4. This is 2. This is 2. This is 4. This is 1. This seems to work also. This is 8. This works also, I think. We have to figure out why the other one doesn't work. Why does 2, 5 not work? So say this is 2, this is 5. This is 1, 2, 3. So this would be 12. So this has to be 5. This is 1. This is 4. This is 9. So this becomes 5, 6, 5, 6. This is 1, 3, 1, 3. This is 6, 5, 4. This is 3, 4, 3, 4. This is 5, 6, 4. This is 5, 6. Okay, German whisper lines look fine. These look fine. That looks fine. This looks fine so far. No 1, 6, no 5, no 9. Can't be 1, this can't be 2, this can't be 4, this can't be 2. Maybe. Two is not in position, 4 is not in position, 1 is not in position, 5 and 6. 5 and 6 are not in position, 8 and 7 are not in position. 8, 6, and 9 are in a position, 1 and 3 are not in position. 4 is in position, 7 is in position, obviously. 5 and 2 are not in position. 1 is in position, 2 and 3 are not, 5 and 7 are not, 6 is, 9, 4, and 8 are not. One is in position, 7 is in position, 4 is not. 8, 6, 8, 9 are not, 3 is not, 2 and 5 are not. 4 is in position, 8's in position, all the rest are not. 2, 7, and 9 are not. 3 and 6 that's not position. 3, 5, and 6, that's also not position. 2 and 8 are in position. 4, 5 are not in position. 3 and 9. 2 and 1 are not in position. 3, 5, 6, and 4 are not in position. 8, yeah, so it's not. This seems like it could be valid. It seems like it's not the correct one. Okay, so what if we try making this 1? So if this is 1, this is 9, this is 8, this is 3, this is 4, this is 7, this is 3, this is 5, 8, 4. So if this is 5, that becomes 1. This is 2 and 3. So this adds up to 17. This is 1, this is 5, this is 2. 6, 5, 9. This becomes a 3. So this is 8, this is 6, this is 7. Which makes that 5, 8, 5, 6, 9. This becomes 2, 1, 6, 3. So that's 4 and 3. 5, 4, 6, 5, 6. That cannot be 1 and 3. Okay, so we know it can't be 1 there. Okay, it seems like it should be a more elegant way of solving that, but I don't know what it is. Right, so this had to be one. This became 1 and 3, which eliminated both possibilities. If this is 1, I don't know. There has to be a more elegant solution, but I don't know what it is. This is 3, 7, 8. So this is 1. This is 8. This is 9. This becomes 2. No 1, 2. No 8, 9. This is 3, 5. This is 6. This is 6. This is 5. This is 8. This can't be 8. So we have 3, 8. No 7. No 1 or 2. This is a 3 because it cannot be 6 anymore. So this is 5. This is 3. 6. Yeah, I'm not sure how. Well, anyways. Which makes that 3 and 4. Okay, so that's 2. This is 1. This is 9. This is 4. This is 5. This is 3. This is 5. 1, 6, 4, 9. 6, 5. This is 2. So this can't be 2. So this is 2. This is 1. This is 3. This is 4. This is 1. 5. 1, 4, 3. Yeah, I'm not sure what the logic is to get this. I think you just have to go through it. You have to run through the situation, unfortunately. I'm not sure I like that. I like it if it's a little bit more clever, but you just have to sometimes you just have that's why sometimes you just have to go down a branch, and just see where it ends up. Because otherwise it's really hard, like especially in variant Sudokus, to know which way it's going, right? Because I don't see how you could realistically can't figure out that this hat could not be 1 because this would have to be 9, and then that would force certain situations where that would have to be a 1, and then this would have to be a 3, and then that eliminates both possibilities there. It just, yeah. Uh, well, that was an average level puzzle. I think for the most part it was pretty average in difficulty, but yeah, that last part was kind of I don't know how else you could do it except for go down a branch and try it out. Um, the question is which branch do you go down correctly, right? Anyways, hope you enjoyed, and I'll see you next time. Take care.